In this lesson, you will learn how to factor trinomials whose leading coefficient is greater than 1. The process that we use is called bottoms up, which is a shortcut to other methods used to factor these trinomials. Let's take a look at a trinomial that does not have a leading coefficient larger than 1 to recall how to use the double bubble method, because we will also be using this method as we go through bottoms up. In this particular problem, x squared minus 11x plus 18, you've learned how to factor this using the double bubble method. Now its leading coefficient is 1. So in this case, we can use a much shorter process for factoring. We have learned to simply take the x squared and split the x's up into each binomial. We then move to the last term and find the factors of 18, which could be 1 and 18, 2 and 9, or 3 and 6. We then choose the pair of factors that add up to the middle term, which is negative 11. If we have no option, in other words, none of these pairs have a sum of negative 11, then we need to move to negative options. So because we're looking for factors of positive 18, we could make both numbers negative because when we multiply, its product is still positive. So we can put negatives for each number in all three situations. Now we can see that we do have a choice because negative 2 plus negative 9 does equal negative 11, our middle term. So we're going to put a negative 2 in one of the parentheses, it does not matter which one, and a negative 9 in the other. And these would be our factors of x squared minus 11x plus 18. Now we're going to use that process as we start learning how to factor problems whose leading coefficient is greater than 1. Let's take a look at this problem. Now notice if we FOILed these two binomials, because these would be the factors of the trinomial at the bottom, we have 2x times x, which is 2x squared, 2x times 2, which is 4x, 3 times x, which is 3x, and 3 times 2, which is 6. If we then combine the like terms in the middle, we would get 2x squared plus 7x, and then our constant would remain 6. Now the question is again, how do we go backwards from here? So how do we get from 2x squared plus 7x plus 6 to the factors of 2x plus 3 times x plus 2? Now, if the leading coefficient is greater than 1, you cannot just do the double bubble method. You must do some additional steps. And we have a shortcut called bottoms up. So what you want to do is this. You want to take this trinomial and create a new trinomial with a leading coefficient of 1 so that you can use the double bubble method. In order to do this, you want to circle your leading coefficient and circle your constant, so your first and your last number in the trinomial. Whatever you did not circle is going to drop down, and it's going to be the beginning of your new trinomial. And notice the leading coefficient is now 1. To get our constant at the end, we're going to take our 2 and our 6, our circled numbers, and we're going to multiply them, and that will now become the constant of our new trinomial. From here, we will use double bubble, as we did in the last problem, and we will factor x squared plus 7x plus 12. However, this will not be our final answer. So if we split up our x squared, then we take the 12, and we find the factors of 12 that have a sum of 7. So we have 1 times 12, 2 times 6, and 3 times 4. And you can clearly see that the 3 and the 4 have a sum of 7, so those will be the factors we choose, or the numbers we choose, for our binomials. Now x plus 3 times x plus 4 are the factors for the trinomial in the middle. They are not the factors of our original problem, so we have not yet finished. Once you've factored the middle trinomial, you then must bring the leading coefficient back into the problem. So it's going to drop down, and we're going to divide both the 3 and the 4 by the leading coefficient. Now, in the first parentheses, 3 and 2 do not divide. So we don't want to leave it a fraction, so we take our bottom number and move it up in front of the x. So it will become 2x plus 3. This is where the name bottoms up came from, because the bottom number, if there's no reducing, has to move up in front of the x. In our second parentheses, because the 4 and 2 does simplify, we want to go ahead and divide those, and that will just simply change to a 2. So 2x plus 3 and x plus 2 are the factors of our original trinomial, and you can see if you go up here that they match. Again, order does not matter. So if you had the x plus 2 first and the 2x plus 3 second, that would be just fine. Let's take a look at some additional examples and work through this process. So in this problem, the factors are 3x minus 1 and x plus 4. And then our trinomial is 3x squared plus 11x minus 4. So you can see if we FOIL this, we would get 3x squared, and 3x times 4 is 12x. Negative 1 times x is negative 1x. And negative 1 times 4 is negative 4. And if you combine the like terms in the middle, you will get 3x squared plus 11x, and then the constant of negative 4. So once again, we want to see how can we go backwards. If we start with the trinomial, how can we get 3x minus 1 and x plus 4 using factoring? So using bottoms up, recall from the last problem, the first thing you want to do is circle the leading coefficient and the constant. And when you circle the constant, include the negative sign because that goes with the constant. Whatever is not circled needs to drop down because you're forming a new trinomial with a leading coefficient of 1 that will allow you to use the double bubble process. We do need the constant at the end of this trinomial, so to get that, we're going to multiply our two circled numbers. So we would get negative 12. We can now double bubble to factor that trinomial. So we will first split up our x's, and we will find the factors of negative 12 and choose the two that would have a sum of positive 11. Because the 12 is negative, you need to make sure that when you write your products, that one of the numbers is negative. Now, sometimes it could be the 1 and it could be the 12, so you need to consider both options. We have negative 2 and 6, and then we have positive 2 and negative 6. We have negative 3 and 4, and we have positive 3 and 4. Excuse me, negative 4. And then you want to choose the pair that has a sum of positive 11. So hopefully you can see that if you add negative 1 and 12, you would get positive 11. So negative 1 should go in one parenthesis, and positive 12 should go in the other. Now remember, so far we've only found the factors of our middle trinomial. We need to find the factors of our first trinomial, our original one. So we now bring the leading coefficient back into the problem and place it under both the 1 and the 12. Then we look at each fraction individually, and if the fraction cannot simplify, we need to move the denominator up in front of the x, which is our bottoms up part of the problem. So we would have 3x minus 1 for our first binomial, and notice that matches. And in the second binomial, because we can divide the 12 and 3, that will simply be x plus 4. So those would be our factors of 3x squared plus 11x minus 4. Let's take a look at another example. In this problem, let's begin by using the FOIL method to simplify these binomials and see if we get 6x squared minus 7x minus 5. So 2x times 3x is 6x squared. 2x times negative 5 is negative 10x. 1 times 3x is 3x. And 1 times negative 5 is negative 5. If we then combine the like terms in the middle, negative 10 plus 3 is negative 7x. We drop down the 6x squared and the constant, negative 5. Now, since we know that those are the factors of 6x squared minus 7x minus 5, let's go ahead and factor and make sure that we can go backwards to get that answer. So using bottoms up, remember, because we have a leading coefficient that's greater than 1, we need to create a new trinomial with a leading coefficient of only 1. To do this, we circle the leading coefficient and the constant, and then we'll drop down x squared minus 7x, so that we are starting to create a trinomial with a leading coefficient of 1. To get our constant at the end of this trinomial, we multiply 6 and negative 5 and get negative 30. Using the double bubble process, we will now factor x squared minus 7x minus 30. So we'll put an x in each binomial. Then we will find all of the factors of negative 30 and choose the pair that have a sum of negative 7. So we have negative 1 and 30, and 1 and negative 30. Negative 2 and 15, and 2 and negative 15. Negative 3 and 10, and 3 and negative 10. And we also have, I'm going to write it over to the right here, 5 and negative 6, and negative 5 and 6. So we need to choose the pair that has a sum of negative 7. And that would be the 3 and the negative 10. So a positive 3 and a negative 10. Remember, at this point, we've only found the factors of the middle trinomial, not the original. So we then bring the leading coefficient back into the problem by dividing both the 3 and negative 10 by 6. Now, in both of these cases, we can reduce these fractions, but we cannot divide them fully. They will remain fractions. So in this case, before you actually do the bottoms up on each of these, reduce the fractions. So when you do this, you will get x plus 1/2 for the first one. And in the second one, you can divide both 10 and 6 by 2, which gives you 5/3. In both of these cases, again, because you do not leave fractions in your final binomials, you take that denominator and do bottoms up on it. You bring it up in front of the x's. So our first binomial should be 2x plus 1, and notice that matches our first binomial in red. Our second binomial is 3x minus 5, and notice that matches our second binomial. So these are, in fact, the factors of our original trinomial, and we've proven that over here because we FOILed it out and we did get the original binomial. Let's do one more example to make sure that you've got this method. 4x squared minus 6x plus 2. Now, in this one, there's one slight difference. You don't want to just start out the same way you did the other problems. The reason is because the first thing you want to do anytime that there's a leading coefficient greater than 1 is look to see if you can factor out a greatest common factor to simplify the problem. And if you look at the numbers 4, 6, and 2, all of them can be divided by 2. So 2 is our greatest common factor. So we're going to take that out, but not remove it completely. And then our leading coefficient will now be 2 when you divide 4 and 2. Our middle term will now be 3x, and our constant will now be 1. Now, the most important thing is don't forget about the 2. So what I do is I go ahead and drop it down and I set up my answer ahead of time. That way I don't forget it. And then I leave space in the middle to show my work as I go through the process of bottoms up to factor this second trinomial, 2x squared minus 3x plus 1. So I'm going to go through bottoms up right now. So I will circle the leading coefficient, which is now 2, and then the constant, which is now 1. I will then drop down the x squared minus 3x, and then find the constant, which would be multiplying the circled numbers, so it would be positive 2. Then using the double bubble method, I will now factor x squared minus 3x plus 2, giving me an x in each binomial. And using the last term, I will write down the numbers that multiply together equal 2, and I only have 1 times 2. However, looking at the middle term, I need those to have a sum of negative 3. So I'm going to have to make both of them negative. Notice the product will still be positive 2, but the sum will be negative 3. So I need to put a negative 1 in one parenthesis and a negative 2 in the other. Now I'm going to go back to my leading coefficient that's circled, the 2, and drop that down and put it under both the 1 and the 2. In the first binomial, 1/2 cannot be simplified any further, so the denominator will need to go up in front of the x. So we have 2x minus 1 for our first factor. I'm going to drop that down. In my second one, because 2 divided by 2 can be simplified to 1, I'm going to go ahead and do that, and then I'll drop that down into my final answer. But notice, because I set it up ahead of time, I did not forget the 2 on the outside. Because if you want to double check this, you could not just multiply 2x minus 1 times x minus 1 and get back to the original trinomial at the very top, the 4x squared minus 6x plus 2. To double check this, once you've FOILed 2x minus 1 and x minus 1, you would then need to multiply each term by 2 to get back to the original trinomial. So that 2 does have significance and needs to be in the final answer when you're factoring. Well, that completes the lesson on factoring trinomials with a leading coefficient greater than 1 using the bottoms-up method.